All right, guys, this is Mr. Corzine. Thanks for joining me for these notes. I'm sorry we couldn't finish them in class here today. I'm not available today in Life Ed. I had to go home, so that's why it's probably extra important that you watch this video and kind of review some things. If you need to rewind, go back, try it again, listen to some different parts again, please do that. Don't just rush through the notes in order to get the homework done. I want you to understand mainly the difference between a combination and a permutation. Okay, a combination and a permutation. So I might go out of order just a little bit, but that's just because I think it's a little easier to present it in a certain way. So for example, I told you the main things are combinations and permutations. So if I have a combination, the combination is just like, hey, you can have any two toppings on your pizza. Like that's basically what you get. You get two toppings. If you are definitely ordering two toppings, well, usually you have a list of things to choose from, right? You got pepperoni, you've got sausage, you've got mushrooms, you've got, let's do olives, and then finally you have, oh, everybody loves anchovies, right? So pepperoni, sausage, mushroom, olives, or anchovies. Now, when you do a combination, it doesn't matter if you do pepperoni and sausage, or if you do sausage and pepperoni. Those are the same thing. So if you're ordering and you say, yeah, I'd like the two topping special, pepperoni and sausage, and they say, well, great, thank you, sir. Well, let me just repeat your order back to you. That's a sausage and pepperoni pizza. That'll be, and you're like, whoa, hold on a second. I said pepperoni and sausage. No, it's the same thing. You wouldn't be correcting somebody on that. So, so order does not matter when you're doing a combination. So how many different combos could you have? Well, if we look further on down in your notes, we've got this big C is your combination. And then, and they've got this like formula that they want you to follow. The number of combinations of n objects taken R at a time. So you got N and C. So how many objects, in this case, how many toppings, and taken how many at a time. So N and R, and it's going to be N factorial over N minus R factorial times R factorial. So that looks complicated, but basically what you're going to do is, if we go back to our pepperoni and sausage, this is going to be our combination of 5 different toppings, but we're only taking 2 of them at a time. Okay, we're only taking 2 of them at a time. So we start with, and I'll come back over here. Maybe I can just move this whole thing over here. We start with this. We look at our formula, N factorial over N minus R factorial. And this is going to be 5 factorial over 5 minus 2 factorial, and then times 2 factorial. So I'm going to make this as simple as I possibly can, like kind of spread it out. 5 times 4 times 3 times 2 times 1. And then at the bottom, it's 5 minus 2. That makes 3 factorial, and then 2 factorial. Okay. So this is 3 times 2 times 1, and then 2 times 1. So we've got these 2 sets of numbers that can kind of cancel some of this out. I got 3 times 2 times 1. That cancels out all of these. And then I've just got 2 times 1. So I've got basically 20 over 2 times 1, which is 2. So guess how many different combinations there are? There are 10. Now, another way of doing this is like this is all this math that you're not gonna memorize all that. So if you think of it another way, you do your pepperoni, sausage, mushroom, olives, and anchovies. Pepperoni, sausage, and mushrooms, and olives. Okay, so you got pepperoni. I'm going to make several columns here. Sausage, mushroom, the other one, olives and anchovies. Olives and anchovies. Okay. I'm going to make a little table here. We're going to do pepperoni and sausage. We're going to do pepperoni and mushroom. We're going to do pepperoni and olives. We're going to do pepperoni and anchovies. That is 1, 2, 3, 4 combinations right there. All right. And then we're going to do for the next one, sausage and what? Pepperoni. Oh, we're not going to repeat that one again. So then we're going to do sausage and mushroom. We're going to do sausage and olives, and we're going to do sausage and anchovies. Okay. All right, let's try the next one. We're going to do mushroom and pepperoni, already done. Mushroom and sausage, already done. So then we're going to do mushrooms and olives, mushrooms and what? Anchovies. For the next one, you see how this is kind of going down, down, down? Now we've got olives and mushrooms. Nope, already done that. Olives and anchovies. And then for the last one, by the time we get here, there's nothing left. So there's nothing that hasn't already been done. So let's count these up real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 different possibilities. So as you're thinking about like running into this on the test, you know, you're not going to have this formula with you. But, I mean, you won't have it memorized, but you will actually have the formula. It's going to be on your reference sheet. Now, this is probably one of those ones where you're like, oh, wait, I don't know what that is. But this is the permutations formula, and this is the combinations formula. So you just have to remember this represents how many of them there are in, and then R stands for like what rate or how many at a time. Okay, so hopefully that makes you feel a little bit better. Also, knowing that you already have the skills to do and work out problems like this. So that is a combination, okay? I'm going to write that in here again, combination. Think of it as like toppings on a pizza, a combination for like making a sandwich. You know, I'm into food. I'm into junk food. This is all really good. But then there's also this example of a permutation. Now, a permutation is where order is important. Okay, order is important. So they give you the example of 6 possible permutations for the letters A, B, and C. Okay, so you've got 3 letters. Okay, and you're taking them 3 at a time. Okay, so this is going to be a permutation of 3 total letters, and you're taking them 3 at a time. Really, we could do this table again, and we could work it out by hand, but we can also use the formula. So this is going to be, it's going to be equal to n factorial over n minus r factorial. Now, I know that sounds a little weird, but now it looks like this. 3 times 2 times 1 over 3 minus 3 factorial. So this is, so it ends up a situation where we got to highlight this. Like you can't have R be any bigger than n, or like you can't have a 0 at the bottom. So if R R and N are exactly the same, then you just do however many there are factorial. So this is 3 times 2 times 1. So it gives you 6 total options. I know maybe that wasn't such a great example, so maybe I'll give you another one, okay? So let's try something like this, where we have the letters A, B, C, and D. And we want to figure out what is the probability that we're going to spell the word dab, okay? D-A-B. Now, that really matters, the order, okay? D-A-B, that really matters. You're really looking for that combo. So it's like you're reaching into your bag for like you're playing Scrabble or something. You reach into the bag and there's an A, a B, a C, and a D. What are the chances that you're going to get it in that order? D, A, B. Well, first of all, when you reach in there, there is a 1 out of how many chances that you're going to get the D? Well, there's a 1 out of 4 chance, right? Okay. Then after that, there is a so that's gone. You already got the D. Then you got to get the A. There's a 1 out of 3 chance you're going to get the A. And then after that, there's a 1 out. So that's gone. Then the last one, there's a 1 out of 2 chance that you're going to get the B. So if you get that, basically what's happened is there were 4 different ways it could have turned out the first time, 3 different ways it could have turned out the second time, and 2 different ways it could have turned out the third time. And then you kind of simplify that out by doing, well, there were 4 total minus 3, and then factorial. So that's really just over 1. Okay, so 4 times 3 times 2 gives you 24 possible combos, and you were looking for that 1 out of there. So you got a 1 in 24 chance. Okay, now maybe that wasn't an awesome example, but usually what's going on here is we're looking for, like, what are the chances that this could happen? Okay, so that's why it ends up looking like a fraction or a probability. Okay, so I'm going to keep going, and we're going to some of these different problems. 7 factorial is just 7 times 6 times 5 times 4 times 3 times 2 times 1. You can multiply that out on your calculator all you want. 7 times 6 is 42, times 5 is 210, 210 times 4 is 840, 840 times 3, oh my goodness, is 2520. Maybe that's 5040, I'm not sure. But you working on your calculator, that's exactly what it looks like. Okay, now for 15 factorial over 11 factorial, let me change this. 15 factorial is 15 times 14 times 13 times 12 times 11, and then it goes this way, right? Well, then 11 factorial is 11 times 10 times, and it goes this way. Well, all of this stuff, all of these 11 times 10 times 9 times 8 is the same up here. So these are going to cancel out. So what ends up happening is you get, and I'll just bring it right back up here. You end up getting 15 times 14 times 13 times 12 over 1. That's going to be your answer. Now, it's still a big number, but that's going to be your answer once you simplify it. Okay, so then for our combinations, this is a combo. There are 11 items, and you're taking them 8 at a time. And there's 11 different things, and you're going to get 8 of them on a pizza at a time. That's pretty crazy. But the formula goes like, what is it? N factorial over n minus r factorial times r. So let's see. N factorial over n minus r factorial, and then what was the last part? R factorial. Okay. In this case, we've got 11 factorial over, let's change colors here. 11 factorial over, what is n minus r? That's going to be 3 factorial, and then times r factorial. So 8 factorial. So if you want to simplify this, you can either simplify these first and use this as a leftover or vice versa. But basically, 8 is going to get canceled out, this 8 factorial. And so you're left with 11 times 10 times 9. This gets canceled out, plus the end of this up here. But then you've also got 3 factorial, 3 times 2 times 1. So when you multiply all that out, what do you get? 11 times 10, which is 110, times 9. What is that? I'm sure that's an easy one, but I'm just going to... Well, now this is way too much work. I should have just done it in my head. We'll get rid of that. 11 times 10 times 9. 990. Should have known that. And then 3 times 2 times 1, that is 6. In the end, 990 divided by 6 gives you 165. That's what this answer should be. All right. I know it's getting kind of crazy here, but let's do one more for our permutation. Now, permutation is where order matters. So let's say there's like 20 letters in the bag for you to choose from in Scrabble, and you're trying to make 4-letter words. How many 4-letter words can you make there? I think it's going to be a lot. I could be wrong, but I think it's going to be a lot. So we look at our formula. It's n factorial over n minus r factorial. So we're going back. 20 factorial over 20 minus 4 factorial. So that's 16, like this. So basically, all of these at the end after 16 get canceled out, right? So we end up with 20 times 19 times 18 times 17 over 1. Okay, so it's going to be a big number that doesn't have as much to divide by. So when there's not as much to divide by, then it just gets the number at the top ends up being a little bit larger. So that's when you have more options, when order does matter. So those are the basics. I'm hoping that makes sense for you guys. So now I want to look at number 5, where it says, how many ways can you arrange all the letters in the word math? Well, when you arrange them, does the order matter? I'm pretty sure it does. So I'll figure out how to get this back. It does matter. In fact, that's the only thing that matters. So we've got this. It's not a combo, because the combination is set. M, A, T, and H, that's the combo. So this is a permutation where there are 4 different letters, and there's 4 different options. So it says in this particular situation, a permutation, the number of permutations of n objects, p to the n is the same as number of objects is the same as the number of times, or how many at a time. Then it's just going to be 1, 2, 3, 4 letters, 4 factorial. So that's 4 times 3 times 2 times 1. So that's 12 times 2. That's 24 possible ways you can rearrange those letters. Okay, we can make a table. You can do M, A, T, H. Then you could do M, T, H, A. And then you could do M, H, A, T. You can see where I'm going with this. And then in the next row, you do the same thing. A, T, H, M. And then A, H, M, T. And going down, going down. So those are the combos. I think at this point I'm going to stop you guys. I'm going to post this so you guys can make sense of it, and then I'll pull up another video for doing your homework.